The story of autopilot systems in cars begins decades ago, seeded by dreams of hands-free transportation. In the 1950s, General Motors first envisioned autonomous cars with their Firebird concepts, which imagined vehicles navigating highways using embedded wires. These ideas sparked an era of innovation but remained a vision on the distant horizon for many years. By the 1980s and 1990s, experimental vehicles like Mercedes-Benz Eureka and Carnegie Mellon's NavLab paved some rudimentary roads toward autonomous driving, albeit with bulky computers and limited intelligence. The true revolution started in the 21st century, as advancements in sensors, artificial intelligence, and mapping technology converged to turn fantasy into reality. Today, major autopilot systems power a new chapter of vehicle technology. Tesla's full self-driving, FSD, perhaps the most publicly recognized, leverages camera-based vision and neural networks. FSD excels in frequent updates and widespread data collection, using millions of user miles to improve. But critics highlight its heavy reliance on vision, limited LiDAR and radar use, and the gap between marketing promises and regulatory approval for full autonomy. General Motors' Super Cruise takes a different tack. With mapped highways and driver attention monitoring, it offers truly hands-off driving in certain scenarios. Its greatest strength is reliability within its mapped domains and strong safety protocols. Ford's Blue Cruise builds on similar principles, with hands-free highway driving enhanced by visual and radar sensors. Strong points include its intuitive interface and expanding network of available routes, though it shares GM's geographic constraints and lacks full urban adaptability. Waymo, Google's autonomous driving arm, sits at the apex of sensor fusion. It incorporates LiDAR, radar, and HD mapping. Waymo's system achieves unmatched accuracy and safety in select metro areas. The challenge for Waymo is limited real-world deployment and slow geographic expansion for consumer use. NVIDIA, with its Drive platform, supplies key hardware and software components to other automakers, enabling AI-driven perception and decision-making. Its strength lies in technological flexibility and advanced simulation capabilities, while it depends on vehicle manufacturers for large-scale deployment. China's Baidu Apollo, Xpeng, NIO, BYD, and Huawei reflect Asia's rapid momentum. Baidu's Apollo Open platform enables collaboration, extensive mapping, and real-world tests, but faces hurdles in user adoption and regulatory environments outside China. Xpeng and NIO are notable for city and highway piloting functions, merging over-the-air updates, advanced AI, and competitive hardware. BYD, known for electric vehicle prowess, increasingly integrates pilot features across its lineup, though often playing catch-up with tech sophistication. Huawei enters the race with an emphasis on high-precision sensors, robust connectivity, and AI, aiming for a holistic vehicle ecosystem. Yet regulatory and consumer trust are hurdles. As autopilot systems become more prevalent, the impact on the car industry and driver experience is profound. Car makers shift from machine builders to software-defined vehicle developers, spawning global competition for talent, patents, and AI expertise. The definition of driving is changing. Safety features prevent accidents, stress is reduced on long journeys, and mobility opens to those previously unable to drive. Yet the transition brings tension. Legal debates over accident liability, insurance adjustments, and ethical questions about data collection. Drivers enjoy increasing convenience, but must navigate new layers of human-machine interaction. Autopilot systems promise to reshape urban infrastructure and traffic flow, but their path is marked by ongoing evolution, regulatory hurdles, and the constant need for vigilance.